Hello students, good morning to all. Welcome to your beautiful channel Firjan. Today we discuss new lesson. So that is a third lesson, current electricity in 12th standard. See, previous we discussed electric charges and fields. In this one, this is the first lesson in 12th standard. We discuss so nearly 17 videos we can did. Yeah. Second lesson, electrostatic potential and capacitance. It is the second lesson. In this one we discuss really 19 videos. So full information I provided. So third lesson, current electricity. It is the third lesson in 12th standard. In this one we discuss different concepts is there. So that all we discuss. So this is the basic concept. So we can start. So myself is ready. It's your cute channel Firjan. Please see the my videos, previous videos, coming videos, and subscribe the channel and share to your friends and relatives. So now we can start the current electricity. It is the third lesson in 12th standard. See here, first what we discuss now, charge. Before going to discuss electric current, we discuss charge first. See, charge. Charge means it is the intrinsic property of matter. It is the intrinsic, it is an intrinsic property of matter. Intrinsic property of matter which produces electric field as well as magnetic field, as well as magnetic field. See here, charge means it is an intrinsic property of matter. Intrinsic means it is basic property, basic property or fundamental property, fundamental property. See here, charge is an intrinsic property of matter. Intrinsic is nothing but basic. It is the basis for electric charge, electric current. So means or magnetism, electric field, magnetic field, all it is the basic. So means that's why we can say that charge is an intrinsic property of matter. It is the basis or basic property, fundamental property, which produces electric field as well as magnetic field. Electric field as well as magnetic field. For example, see, charge is at rest, it produces electric field, it produces electric field. See, charge is at rest, it produces electric field. Charge is in motion, charge is in motion, it produces magnetic field, magnetic field. So electric field now, it produces electric field, it produces magnetic field. See, charge is at rest, it produces electric field. Charge is in motion, it produces magnetic field. See, study of charge, study of charge at rest, we call it as electrostatics. What is the name? Electrostatics. See, study of charge at rest, we call it as electrostatics. In electrostatics we discuss different parts is there. See what we discuss now here, electric charges, electric fields, electric field, about electric field, electrostatic potential, electrostatic potential, capacitors, and series and parallel connection of capacitors. This all we discuss. Already we completed this two lessons. It is the first lesson is electric charges and fields. Second lesson is electrostatic potential and capacitors. So these two lessons we discuss, we give brief information. So it is very useful actually. Next now, study of charge in motion, we call it as electrodynamics. Electrodynamics. See here, study of charge at rest, we call it as electrostatics. In electrostatics, what we discuss now here, electric charges, electric fields, electrostatic potential, capacitors, series parallel connection of capacitors, how to solve the different types of circuits with different methods. We discuss concentric cells, everything we discuss that one. See, study of charge in motion, we discuss. So, study of charge in motion, we call it as electrodynamics. In electrodynamics, what we discuss now here, see, what are the concepts involved now here? Current, electricity, magnetism, electromagnetic induction, AC current, and electromagnetic waves. This all we discuss in study of charge in motion, that we call it as electrodynamics. In electrodynamics, current, electricity, magnetism, moving charges and magnetism, magnetism and matter, electromagnetic induction, AC current, electromagnetic waves. This all discussed in electrodynamics. Yes, na? See, it is the basic concept. See here what na? Charge means it is an intrinsic property of matter which produces electric field as well as magnetic field. Charge is at rest, it produces electric field. Charge is in motion, it produces magnetic field. Study of charge at rest, we call it as electrostatics. In electrostatic, electric charges, electric fields, electrostatic potential, capacitors we discuss. A study of charge in motion, we call it as electrodynamics. In electrodynamics, these all concepts, current, electricity, magnetism, electromagnetic induction, AC current, electromagnetic waves. So this we discuss. See, current, electricity, it is our now concept. It is the third lesson in 12th standard. See, current, electricity. In this one we discuss what is electric current, what is the resistance, what is the resistivity, conductivity, conductance, series connection of resistors, series connection of cells and cells, bulbs, power. This all we discuss this one. So first concept now here. So electric current. In this one we discuss first electric current. So what is electric current? That we discuss. See, first electric current means rate of flow of charge. Rate of flow of charge, we call it as electric current, or we can write net charge. Net charge flown through cross section of conductor, cross section of conductor in unit time. Unit time, we call it as electric current. Electric current means rate of flow of charge or net charge flown through cross section of a conductor in unit time, or we can write the speed at which the speed at which charge can flow, charge can flow, we call it as electric current. See, electric current, how to represent na? Electric current, see how to represent, either small letter I or capital letter I. So electric current equal to charge flown by time taken, time taken or unit time. So this is called as electric current. See, electric current means rate of flow of charge or net charge flown through cross section of a conductor in unit time. For example, see here, it is the conductor. See, it is the area of cross section we selected. It is the area of cross section. In this area of cross section, how many electrons passes through this area of cross section in unit time? Unit time. So means in unit time means t time. How many charges passes? See, charges passes. That we call it as electric current. Means number of charges, total number of charges passes through cross section of a conductor in unit time, in t time. So that we call it as electric current. See here, q charges passes through cross section of conductor, this cross section a. I mean, how much time? T time. So means q charges passes through cross section in t time, we call it as electric current. So that we can write here, see, q by t. So means charge flown means total number of charges passes through cross section of area a in t time, that we call it as electric current. Charge by time, we call it as electric current. See here, charge na, what is the unit of charge na? Coulomb is the unit of charge. Time na, second is the unit of time. See, coulomb per second is the unit of electric current in SI system. This we call it as ampere. Ampere is the unit of electric current in SI system. Means in system of international we can measure how to na, unit is the ampere. It is the basic fundamental quantity. It is the basic or fundamental quantity. See here, electric current means rate of flow of charge or net charge flown through cross section of a conductor in unit time. Net charge means here total charge. Total charge passes through cross section of a conductor in unit time. In unit time means in t time, how much charge passes through this cross section? Q charge. So charge by time, we call it as electric current. That only we write here, charge flown by time taken, q by t. Charge na coulomb, time na second. Coulomb per second we call it as ampere in SI system. Yes na? See here, for example, here we can take, it is the conductor. See, it is the area of cross section. In this area of cross section a, delta q charge passes through in delta t time. So that we call it as average current. See, average current, I average equal to delta q by delta t. Means in delta t time, delta q charge is passes through this cross section area. So that we call it as average current. See, for example, here in this area of cross section, so dq charge in dt time it passes. So that we call it as I instantaneous. Means instantaneous current. Instantaneous current means the number of charges flowing through cross section of a conductor in dt time. Dt time, how many charges passes? Dq charges passes through this area of cross section in dt time. That dq by dt we call it as instantaneous current. This in average time means, average current means dq delta q charge in delta t time, that we call it as average current. Average current means delta q charge is flown through, passing through this cross section in delta t time, that is I average. It is dq charge passes through dt time, that we call it as I instantaneous. Instantaneous means in particular time, how much of charge is passes through cross section of a conductor, that particular time number of charges passes, that charge we call it as instantaneous. In interval means in between some particular time, means long interval. So means 0 to 3 seconds, 0 to 5 seconds, that we call it as average current. So delta q time, in long period of time, how much charge is passes through delta t time, so that charge we call it as electric current, average electric current. Instantaneous particular time at 2 seconds. How many charges passes through cross section of a conductor? dq charges passes through at dt time. Particular time 3 seconds, at 3 seconds, at 4 seconds, at 5 seconds. So particular time, how much charges passes through cross section of a conductor? dq charge passes through dt time. That we call it as instantaneous current. See, we have electric current means rate of flow of charge, net charge flowing through cross section of a conductor, or speed at which charge can flow, we call it as electric current. See, electric current means charge flown by time taken, q by t. What is the unit? Coulomb per second. We call it as ampere. What is the symbol now here? A. It is the symbol of electric current. What is the dimensional formula now? See, either we can write capital letter I or A. It is the dimensional formula of dimensional formula of electric current. Electric current, why not? It is the basic property, means fundamental property of quantities, fundamental quantity. So it is either I or A. It is the fundamental quantity. So it is the, what is the dimensional formula for electric current now? Either I or capital letter A, capital letter I or capital letter A. So that is the dimensional formula of electric current. See, what is the unit now here? Ampere. We can represent symbol A. How to measure this electric current now? By using ammeter. It is the device which is used to measure the electric current. What is the device name now? Ammeter. It is always connected in series in the circuit. Series in the circuit. Why it is always connected in series in the circuit now? In series, current is same. In series connection, either capacitors or inductors or resistors, so current same in series connection. So that's why it is connected in always series. So it measures electric current. What? Ammeter. Ammeter is always connected in series. Why? Because in series connection current will be same. Current is same. That's why it is connected in series connection. Ammeter is always connected in series connection. It is the basic information. So about this we can do the some problems. See, electric current na. See, what is the first one na? See, I write here first problem. See, q equal to t square plus 4t plus 5. Find I instantaneous at 3 seconds, at 3 seconds, and I average at I average between 0 to 2 seconds. It is the problem. First see here, q equal to charge they give. What is the charge? T square plus 4t plus 5. Find I instantaneous at 3 seconds, at third second, and I average between 0 to 2 seconds. First we can find out I instantaneous. What is I instantaneous? I instantaneous means dq charge passes through cross section in dt time. So means we can write dq by dt. So here d by dt of q means what? This only now. We can write here t square plus 4t plus 5. See here, at what we find out? At 3 seconds, t equal to 3 seconds, we find out what is the instantaneous current at third second. So that's why the here d by dt of t square plus 4t plus 5. We know differentiation. D by dt of d by dt of x power n equal to n into x power n minus 1. It is the formula. Yes na. So power is coefficient, its power is decreased by 1, and that we get. See here, what we get now here, d by dt of t square plus 4t plus 5. T square means 2t, d by dt of t square means 2t. Power is coefficient, power is reduced by 1, 2 minus 1. See here, 4t. What is d by dt of 4t? Means 4 is constant. So d by dt of t means 1. We can write here. So d by dt of constant means 0. We can get here 2t plus 4. So what here? dq by dt at t equal to 3 seconds. Yes na. Where t is there, we can write 3. 2 into 3 plus 4. What we get here? 2 3 are 6 plus 4. So what now we get? So 10 amperes. What is the current? Instantaneous current at 3 t equal to 3 seconds? 10 amperes. Q equal to t square plus 40. Find I instantaneous at third second and I average between the 0 to 2 seconds. I instantaneous means dq by dt. What d by dt? Q value is t square plus 40 plus 5. We can write here t square means 2t, 40 means 4. dq by dt at t equal to 3. So where t is there, there we can write 3. 2 3s are 6 plus 4, 10 amperes. What is the current now? Instantaneous current, 10 amperes. So now see I average. I average means delta q by delta t. Means long interval. So means in interval of time. What now here? 0 to 3 seconds, 2 seconds, sorry. 0 to 2 seconds. What now q here? T square plus 40 plus 5 means q at 2 seconds minus q at 0 seconds. We find out and t2 minus t1. So means t2 minus t1 we can write. Q now here what? T square plus 40 plus 5. Where t is there, there we can write 2. We can find out here. See 2 square plus 4 into 2 plus 5 minus where t is there, there we can write 0. So final time is 2. We can write here. Initial time is 0. We can write 0 square plus 4 into 0 plus 5 by final time 2, initial time 0. What we get here? 2 square means 4, 4 2s are 8 plus 5. Here 0 square 0, 4 into 0 0 minus 5 by 2. So means this minus 5 plus 5 cancel, 8 plus 4, 12 by 2, 2 1 2 6. So what is the current now here? 6 amperes. What is the I average? So means average current equal to 6 amperes. What is the average current in 0 to 2 seconds now? 6 amperes. Instantaneous current 10 amperes at third second. At third second, what is the current now? 10 amperes. In between 0 to 2 seconds, what is the current now? 6 amperes. It is the problem. Yes, na? See, second one we can do. See here, what na second one? Second problem, see, I equal to t square plus 1. Find charge flown through flown through cross section between 0 to 3 second. 0 to 3 second. Also find charge number of electrons, number of electrons flown that time, number of electrons flown that time, flown at that time. See here, what is the problem now? I equal to t square plus 1. Find charge flown through cross section between 0 to 3 seconds. Also find number of electrons flown at that time. So we can find out that one. See here, what now here? First we can write here where to where 0 to 2 seconds. I they give. So I equal to what? We can take here instantaneous current dq by dt. See here, see dt changes to this side. So what we get? dq equal to I dt. Yes, na? See, integrate both sides. So what we get? dq means q we get integral I dt. So I dt where to where? 0 to 3 seconds. I write here 0 to 3 seconds. What is I value here? I equal to t square plus 1 dt. See here, integral x power n dx equal to x power n plus 1 by n plus 1. Yes, na? It is the formula integration na x power n dx equal to x power n plus 1 by n plus 1, means power increased by 1 and n plus 1 we can write. Yes, na? This is the formula. Here see, integral 0 to 3 t square plus integral 0 to 3 1 dt. We can separate here. T square means power increase na, t power 2 plus 1 by 2 plus 1 means 3 by 3. Where to where interval? 0 to 3 seconds plus integral 1 dt na t only. Yes, na? So what is the interval? 0 to 3. So we can write here. So 3 cubed by 3 minus 0 plus 3 minus 0. Yes, now see here 1 3 cancel. So what we get here 2. 3 square means 9 minus 0 plus the 3 minus 0. What we get here 12 coulomb. What is the charge flown in 0 to 3 seconds now? 12 coulombs. What is the charge flown through cross section of a conductor in 0 to 3 seconds now? That is dq equal to, sorry, q equal to 12 coulombs of charges passes through cross section of a conductor in between 0 to 3 seconds. See what we want here, find the number of electrons flown at that time. In 0 to 3 seconds, how many electrons passes through cross section of a conductor? That also we find out. What is the formula for charge? So charge equal to plus or minus Ne. Here q means charge, total charge flown at that time. N means integer, E means charge on electron. Charge on electron. See Q now here, what is the charge? 12 coulomb. See here, plus or minus N means integer. E means charge on electron. What is the charge on electron? 1.6 into 10 power minus 19 coulombs. Yes, na? See Q means total charge, plus or minus, N means integer. We don't know, that only we find out. See E means charge on electron. Charge on electron is 1.6 into 10 power minus 19 coulombs. See here, this coulomb cancel. So N equal to what we can write here 12. It is changes to this side means 12 by 1.6 into 10 power minus 19. See here 12, it is changes to numerator means into 10 power minus 19 by 1.6. Here point remove now, what we get 120 by 16 into 10 power 19. See here 16 8 jar, so no 16 7 jar 112, yes 16 5 jar means 7.5. So 7.5 into 10 power 19 electrons. How many number of electrons flown between 0 to 3 seconds na? 7.5 into 10 power 19 electrons. See I they gave, we want to find charge flown through cross section between the 0 to 3 seconds. Also find number of electrons flown at that time. See for that we can take I equal to dq by dt. So dq now, here we want to find charge, so that's why dt changes to here, dq equal to I dt. Integrate on both sides. So dq means q, integrate I dt. Where to where? 0 to 3 seconds. We can take here 0 to 3 seconds. Q equal to 0 to 3 seconds. I means t square plus 1 dt. We know x power n, integral x power n dx equal to x power n plus 1 by n plus 1. This is the formula. Here see, t square I write separately, 1 separately. T square na t cubed by 3, 1 na t. So we can substitute upper interval, lower interval. We get what is the charge? 12 coulombs. See here q equal to 12 coulombs. So actually q means here charge. Charge equal to plus or minus Ne. It is the formula, total charge equal to plus or minus Ne. N means integer, E means charge on electron. We can take here what is the total charge? 12 coulombs equal to plus or minus N into charge on electron is 1.6 into 10 power 19 minus 19 coulombs. Here coulomb cancel. So what we get here? N equal to 12 by 1.6 into 10 power minus 19. This 19 is changes to numerator means plus 19, sorry, plus 19. 12 into 10 power 19 by 1.6. Point remove now, what we get here? Numerator 0 added. 16 7 jar 112, 8 is there, point 16 5 jar 80. So 7.5 into 10 power 19 electrons. Number of electron flown at that time is 7.5 into 10 power 19 electrons. Yes, now this is the problem about electric current. So now we discuss electron gas model or classical story of electric current. So electric current have some classical story, what is happen inside the conductor. So that all we discuss. See here electric current. Yes, now in this one electron gas model, or we can write classical story of electric current. Electric current. See, this we call it as actually a drift velocity. We find out drift velocity. For that, we discuss electron gas model or classical story of electric current. Drift velocity. See, for that, here what we can do now? We can take one conductor. See, let us consider it is the conductor. Yes, it is the conductor. See, here external electric field is there. It is the external electric field. So it is, what is the direction of external electric field now? Left to right it is moving. It's not external electric field. Because of external electric field, it is the conductor. In conductor inside, different charges is there, positive charges, negative charges is there. See, we know it is the electric field now. Plus q charge moving in the direction of electric field, minus q charge moving opposite to electric field. See, because of external electric field, plus q is moving positive charges in this direction and accumulated here. Positive charges are accumulated one end. Negative charges moving opposite to electric field accumulated here. See, it is the conductor, we know. So means how many charges inside is there? All charges are induced because of electric field. See, here we know already one formula, sigma I equal to sigma into 1 minus 1 by k. So means here k means dielectric constant. Before lesson we discussed. So dielectric constant for conductor is infinity. So means this value is totally 0. So what here, sigma I equal to sigma, we get how many charges is there? Means sigma means here surface charge density, number of charges per unit area. So that is sigma I means how many charges is there in this one? All is induced, means because of this external electric field. That's why, what is the electric field now inside a conductor now? It is positive to negative electric field. This is called induced electric field. See here, due to external electric field, positive charges moving and accumulated at one end, and negative charges moving and accumulated another end. Due to the accumulation of positive and negative charges at different ends, electric field is produced. Why now? Positive to negative is there always electric field. These are induced charges. So due to this induced charge, electric field is produced. That we call it as induced electric field. See here, E induced equal to E external, but both are in opposite direction. One will be left to right, another will be right to left. It is the induced electric field, it is the external electric field. What is the net electric field now? Here see, E net equal to E external minus E induced. See what now here, net electric field is 0. But see here we have isolated conductor. Yes na, in this one, see here, what now here, it is the temperature, for example 27, it is the temperature here 24 degrees. Yes na, here 27 degrees, here 24 degrees. Here what is the net electric field? 0. But here electron still moving. Why na? This is the reason. See here, outside is 27 degrees, inside is 24 degrees. See, it's means here, because of here temperature difference, temperature difference, what happened now here, heat is produced, heat produces. Yes now, see here, because of outside is 27 degrees, inside is 24 degrees, because of its temperature difference, what happened now here, heat produces. It causes thermal energy. It causes thermal energy. Because of this thermal energy, in the absence of net electric field, in the absence of net electric field, electrons still move inside conductor with thermal velocity that is 10 power 4 to 10 power 5 meter per second. In electrons are moving in random motion. What is the motion now here? Random motion. Electrons are in random motion. See here, in the absence of net electric field, electrons, see here, electrons still move inside the conductor with the thermal velocity 10 power 4 to 10 power 5 meter per second. So electrons moving in random motion. See here, because of this temperature difference, actually here what, net electric field which is equal to net sorry external electric field which is equal to individual electric field. Individual electric field is due to external electric field, all positive charges accumulated at one end, all negative charges accumulated at another end. Because of accumulation of individual charges, an electric field is produced inside the conductor, that is called individual electric field, which is exactly equal to external electric field. So means net electric field means E external right side, E individual left side. So both are opposite direction. That's why E net is 0. But still electrons move inside the conductor. Why na? Here temperature is 27 degrees. Here temperature is 24 degrees. Because of this temperature difference, heat is produced. Heat produces, it causes thermal energy. It produces thermal energy. This thermal energy is absorbed by the electrons. So in the absence of net electric field, external and individual electric field absence, but still electrons move inside the conductor with thermal velocity, that is 10 power 4 to 10 power 5 meter per second. That electrons are moving in random motion. So how it will move now? Here electrons, one electron will be this direction, one will be this direction, one will be this, so one will be like this, it will move. So electrons are moving in different direction. It is, its velocity is u1, its thermal velocity is u2, its thermal velocity u3, u4, u5. So electrons are moving in different thermal velocity. These are in random motion. In random motion, random motion. See, average velocity of one electron, average speed is not 0, but average velocity equal to 0. Average velocity equal to 0. Why average velocity equal to 0 na? We can consider velocity means direction and magnitude. So that's why average velocity is 0. What is that average velocity now? Here average velocity equal to u equal to what now? Here u1 plus u2 plus u3, so on un by n. So this value is 0. Average velocity of the electrons inside the conductor in the absence of net electric field is 0, but electrons still moving inside the conductor. Electrons still moving inside the conductor. This is the, see here again, once listen before. See here, it is external electric field. Because of external electric field, positive charges accumulated here, negative charges accumulated here. So how much external electric field is there? That much individual electric field is. Why? Because in conductor all the charges are induced. Because of this one, see, sigma I equal to sigma into 1 minus 1 by k. What is the k value for conductors? Infinity. So 1 by infinity 0. So means sigma I equal to sigma means here surface charge density. How many charges is there? All will be induced. Because of that, how much external electric field is there? Same electric field inside the conductor due to individual charges. So that is individual electric field equal to external electric field. So means what? Net automatically 0. Why? Because both are same magnitude, opposite direction. See here, because of the temperature difference, this what now? Here heat is produced, it causes thermal energy, it will be absorbed by the electrons, still moving inside the conductor with the thermal velocity. But in the absence of net electric field, electrons are still moving. Why? Because of temperature difference produces heat, causes thermal energy. So because of this absorbing thermal energy, it are moving with a thermal velocity 10 power 4 to 10 power 5 meter per second. It is moving in random motion. So this is because of this random motion, what happened now? Here see, average speed is not 0, but average velocity is 0. That average velocity is here u equal to u1 plus u2 plus u3 plus u4 plus u5 plus u6, so on, equal to 0 by n, equal to 0. Average velocity of electrons inside the conductor is 0. Average speed is not 0. Yes na? This one. So now this, see, this conductor here, it is the conductor. Now what we can do now? Here it is connecting wire across the conductor. See here, it is connecting wire. Now what we are doing now? Connecting wire across conductor, across conductor. See here, actually what before, in the means net electric field is 0, but in the absence of net electric field still electrons are moving inside the conductor because of thermal energy. This thermal energy is how they are getting na, how it gets na, because of temperature difference. So because of thermal energy electrons still move inside the conductor with 10 power 4 to 10 power 5 meter per second in the absence of net electric field. Yes na, see this will be connected to electric means wire connecting, so means connecting wire across the conductor with battery. See here it is connected. What happened here, this battery supplies energy, so means cell supplies energy, it is positive negative, electrons are taken moving here this direction and here. So what electrons are moving means here what, so charge is decreased, charge means induced charge is decreases. So induced charge decreases, what happened here, electrons either it absorb means positive charges absorbing. So like this means what happened, electrons are moving in the conductor. Yes na, means here E induced, E induced decreases because of wire connecting wire across the conductor. When E induced decreases but not 0, so means but E net minus E induced, E induced equal to what now here, not 0, it will be equal to 0. So that case electrons are moving in the conductor, because of moving electrons what happened na, current is produced. See here this, here now what now here, for example see it is the electric field. Yes, here negative charges, positive charges will be moving in this direction, negative charges in this direction. Here see QE, what is the force on charged particle? So what is the force on charged particle? Force equal to Q into E. Q means what here? Electrons are moving. Yes, na? See, electrons are moving means here minus E electric field. So force means actually M A mass into acceleration. See here acceleration of electron equal to minus E by M. It is the acceleration of the electron. Means because of connecting wire across the conductor, electrons are moving with some acceleration. So that is here A equal to minus E by E capital E by M. Means electrons moves with acceleration. So means and velocity increases. Alright, here see it seems that electrons will move with acceleration A and its velocity is keep on increasing, but due to continuous collision with kernel, velocity of electron keep on decreases. Overall electron moves with constant small velocity, constant small velocity in a direction opposite to net external electric field called drift velocity. It is called drift velocity. See here, it is connecting with wire. What happened here? Electrons are moving. Here decreases electrons automatically moving here to here this side. So means like this electrons are moving when wire is connected. Yes, na? What happened here in E induced decreases. When E induced decreases, automatically it will be moving. Before its accumulation is there, so it stops. So that's why it will be, it stops in this side, this side. So it maintains constant. So that when here electrons moving this direction, what happened here, some difference is there, potential difference, because of that current is, means electrons are moving automatically, current is produced. See E net equal to E induced decreases to 0, not exactly, approximately it is 0. So means E net minus E induced equal to 0, but not exactly 0, it approximately equal to not 0, but it will be near to 0. So due to that, what happened? Some force is acting on the electron. What is the force? That one, F equal to QE. F equal to QE. Now Q means here electron minus E power, means minus E plus E. So here F equal to what? Ma. A equal to what? Minus E by E into capital E by M. Here acceleration of the charged particle is minus E capital E by M. So means see here, it seems that electron will move with acceleration. Its velocity keep on increasing, but continuous collision with the kernel. Kernel means other part of electron. So means this electron collided with the other part of electron. That means kernel. It is collided with the kernel. What happened? Come to rest. Again moving. Come to rest. Again moving. Like this it will happen. Because of these collisions, collision means one charged particle affect other charged particle. So that is called collision. Because of collision, what happened here? One charged particle affect the speed of other charged particle. Speed of one charged particle affecting other charged particle. Speed of other charged particle, that we call it as here collision. Because of collision, its velocity keep on decreases. Its velocity decreases, before increases, now decreases. Overall, electron moves with constant small velocity in a direction opposite to net electric field. We call it as drift velocity. That is called drift velocity, that we derive now drift velocity formula. Yes na? See what happened now here, electrons are still moving now inside the conductor. See, I write here. So electrons are moving. So this electron, for example, this one, it is moving with thermal velocity. What? U1. It reaches to V1. It is collided with the kernel. Kernel means other part of electron. That is called as kernel. It is kernel. Kernel means other part of electron. Because of this other part of electron, this electron collision with this one, what happened here? U1 to V1 reaches, it come to rest. So come to rest how much time? Tau 1 time. See again it will start. See, because of change in means because of electric field. See here, it's again U2 velocity, it reaches to V2, again it collided with the kernel. So what happened here? Again it started U3, it reaches to V3, again collided with the kernel. What happened here? Again it will start. Here see, U4, it reaches to V4, again it is collided with the kernel. What happened here? See, it reaches here. So it is electron. See here, it is the initial position, it is the final position. What is the displacement here? Very less. Yes na? See, distance now more is there, but the displacement is less. See, because of that, actually its initial velocity is 10 power 4 meter per second to 10 power 5 meter per second. Because of thermal energy, it was moves with thermal velocity. Because of this collision with the kernel, what happened? Comes to rest. How much time? Tau 1 time. It's also come to rest. How much time? T2 time. Here come to rest. How much time? T3 time. Yes na? See, it will come to rest. Here T4 time. Here T5 time. So means what happened here? Tau means relaxation time. Here now it is the distance between the two successive kernels. We call it as free path. Free path, it is relaxation time. Relaxation time. Relaxation time means it will, after collision with the kernel, electron come to rest. That we call it as relaxation time. Means time interval between the two successive paths, two successive collisions, sorry, time interval. So it means two successive collisions. Two successive collisions, what is the time is there? That we call it as relaxation time. What is the path between the two successive collisions? That we call free path. It's not here tau 1, tau 2, tau 3, tau 4, tau 5, like this. Here u1 velocity, it reaches to v1, collision with the kernel and come to rest. Again started u2, again final velocity v2, again u3, v3, so again u4 final initial velocity, again it reaches to v4, come to rest with the kernel, collide with the kernel, again u5 reaches to v5, again come to rest. Means here, see, from here to here we can say now what is the displacement here? Very less. So that's why 10 power 4 to 10 power 5, it's initially it has, it will decreases to how much now? Decreases to what now? Here 10 power minus 4 to 10 power minus 5 meter per second because of collision with the kernel. Collision means here the speed of one charged particle affecting the other charged particle, that we call it as collision here. So because of collision with the kernel, its speed is 10 power 4 to 10 power minus 4, it decreases. 10 power 5 to 10 power minus 4 minus 5 meter per second, it decreases because of collisions. So what is the speed of the charged particle inside the conductor na? 10 power minus 4 to 10 power minus 5 meter per second. Yes na? So like this it will happen. See here, we can find out what is the final velocity. V1 equal to, you know, in 11th standard we learned velocity equal to what now? Final velocity equal to u plus at. So this electron has acceleration a, yes na? Time t here tau 1. What is the initial velocity u1? We can write here u1 plus at, acceleration a tau 1, v2 u2 plus acceleration a tau 2, v3 u3 plus acceleration a, time is relaxation time is tau 3. Like that we can write vn un plus a tau n. See, this all added we get the average velocity. See, v average equal to v1 plus v2 plus so on vn by n. Yes na? Here see, v average equal to v1 means u1 plus a tau 1, v2 means u2 a tau 2 plus so on un plus a tau n by n. It is the average. So we can separate initial velocity is common. See, I write here v average equal to u1 plus u2 plus so on un by n plus acceleration common tau 1 plus tau 2 plus so on tau n by n. Yes na? See, this one we know what is the average velocity of the charged particle na? We know that one. So what is 0? So what we get here, v average equal to a tau 1 plus tau 2 plus tau n by n na? Tau average, we are getting what is the average velocity of charged particle inside the conductor. Now v average equal to, when it is connected with wire na, see, v average equal to a tau average. Tau means here average relaxation time. So we know acceleration formula. Shall I erase this one? See this part, see here, see v average equal to a into tau average. Tau means here average relaxation time. A means acceleration. Already we find acceleration what? E, capital E by m. Minus we can write here. We can take magnitude na. A equal to what? E. E means charge on E means charged particle. Here na electron only here. Capital E means electric field. M means mass of the electron. See, here we can write V average equal to E capital E by M into tau average. It is the average velocity of an electron when the conductor is connecting wire across the conductor. That case, what is the average velocity of the electron? E capital E by M tau average. Here E means charge of electron, E means electric field, M means mass of the charged particle, tau average means relaxation time, average relaxation time. Yes na? See, this is the drift velocity. What is the formula for drift velocity na? Drift velocity means starting electrons are moves with thermal velocity, what, 10 power 4 to 10 power 5 meter per second. It's means it has acceleration, it moves with the thermal velocity, its velocity is keep on increases. Because of collision with the kernel, its velocity is continuously decreases. Because of decreasing and increasing velocity, overall electron moves with constant small velocity in a direction opposite to electric field, external electric field. That small velocity, small constant velocity, we call it as drift velocity. That drift velocity formula is here E capital E by M tau average. For example, see here, it is the conductor. Yes, its potential difference is V. its length is L. Here its electric field is E, external electric field is E. This case, what is the relation now here? V equal to EL minus EL. Actually we can take magnitude minus EL, so we can take magnitude. So means E equal to what we can write? V by L, means potential difference by length. See here, instead of E we can write V by L na. So means V average, we call it as drift velocity. See that drift velocity we can write it as here E. E means V by L, M already is there, tau average. It is the formula for drift velocity of charged particle when connecting wire across the conductor. That case, what is the drift velocity of charged particle? EV by ml tau average. Here E means charge of electron, V means potential difference, m means mass of the charged particle, n means L means length of the conductor, tau average means average relaxation time. It is always moves from lower potential to higher potential. Why not? Charged particle is always moves from lower potential to higher potential. So what is the drift velocity of electron na? Is drift velocity Vd equal to Ev by ml tau average. It is the drift velocity formula. Yes na? It is about drift velocity. Drift velocity means electron moves with small velocity. Why it will move with small velocity? Starting it has keep on velocity increases. Later what happens? Because of collision with the kernel, its velocity decreases. So that's why overall electron moves with small constant velocity in the direction opposite to net electric field, external electric field. We call it as drift velocity. Yes na? So drift velocity formula is drift velocity Vd equal to Ev by ml tau average 1, or we can write E capital E by m tau average. It is the formula for drift velocity. Yes na? See, now we discuss a relationship of electric current with drift velocity. Yes na? See here in this one, see relationship of electric current with a drift velocity. A drift velocity. What is now here relationship that we've discussed? See here, for example, here it is the conductor. Yes, we can select here some region. It is first one, it is second. In this region, here electrons are moving from here. See, electrons are, yes na. See, what is electric current na? Net charge flowing through cross section of a conductor in unit time. See, it is connected to wire. What happened now here? Some charge is flowing through this one. See here, the number of charges flowing in cross section in cross section, number of charges flowing in cross section, across cross section in dt time, we call it as total number of charges, that equal to here. So means number of charges in the shaded region. See, for example, here it is the region we can take. It is 1, it is 2, its distance is some L. These electrons are moving with Vd, drift velocity. How much time na? Dt time. So means length equal to what? Actually speed into time. What is speed here? Vd, time is dt, means this distance is what here? Vd into dt, speed into time. Here see, its area of cross section is A. Yes na? See, in this area region 1, so means number of electrons passing through cross section of a conductor unit time. See, for example, in dt time, in this region, in this area crosses some electrons, number of charges. So that number of charges passing through cross section of a conductor in dt time, that we call it as electric current. Here see, in this dt time, this number of charges passes now here, how many charges passes this region, so that in this area of cross section that will be here is there. So mean that's why we can write here number of charges flowing in cross section 1 in dt time equal to number of electrons in the shaded region. In the shaded region, how many number of electrons is there? That will be passes in dt time in this region 1. So that we can write here. See, the number of electrons passing or crossing the cross section, cross section in dt time, we can write it as dq, number of charges. Dq equal to number of charges into charge on electron. So number of charges or number of electrons in that region into charge on electron. See here number of charges now here. So in this region, how many number of charges is there? We know, we don't know. So this means here n means number density. Number density means number of charges or number of electrons, free electron per unit volume. Per unit volume we call it as n. So means number density means, for example, we can take 1 meter cube. So 1 meter cube means length 1 meter, width 1 meter, height 1 meter. So in this 1 meter cube volume, how many electrons is there? How many free charges is there? That we can say that number density. Here see, in this volume, how many number of electrons is there? So means n electrons is there in this volume. For example, in this volume, what is the area? This one a. What is the length here? Vd into dt. Why? Because here length is not given, speed give, time give. So Vd into t is called, dt is called the length of the this region, and area is a they give. So means how many number of electrons? N electrons into number of electrons per unit volume. What is the volume here? Area into length. Length means what here? Speed into time. What is the speed of electron here? Vd into time is what? Dt time. Yes na? See, into what is here? Number of electrons in that region into charge on electron. What is the charge on electron? E. So we can write here, see, dq equal to what we can write now? Number of electrons in this region, n electrons is there. What is the volume of this one? Volume means area into length. Area is what? A. Length means what here? Length is not given, but speed give, time give. Speed is what? Drift velocity. Time dt. We can write here drift velocity is vd, time is dt, and what we can write? Charge on electron. What is the charge on electron? E. So dq equal to what we can write now? Vd E n a into dt. Here dt changes to this side. What we get here? See here dq by dt equal to vd means drift velocity, e means charge on electron, and n means number of charged particles, number of free charges, a means area of cross section. So dq by dt means I only na, electric current na. So equal to vd e na. It is the relationship of electric current with drift velocity. I means here electric current, vd means drift velocity, means e means charge on particle or charge on electron, n means number density, number of charges, free charges per unit volume, a means area of cross section. See here vd we know before we derived, vd equal to what? ev sorry e into electric field by m into tau average. Yes na? We can write here I equal to e capital E by m into tau average into E into N into A. Here see E means what? E equal to electric field equal to potential difference by length. See we can write here, see I equal to E V by ML tau average into E into N into A. We can write this one, what now here? N E, here E is there, E square tau, we can write tau average, A is there, A V by ml. So what is the electric current formula? Na? I write here electric current I equal to, we can write first one what? VENE means Vena. Second one is, see, NE square tau AV by ml. See here we can have what is the electric current formula? Na? Vena, VENA, Vena one formula, NE square tau AV by ml, or we can write Q by T also. We have general formula this one. These are the formulas for electric current. Yes, na? This is the concept, basic concept in current electricity. It is the first video. So I think it is very good. Please see the videos, like and subscribe the channel and share to your friends and relatives. Thank you.